Chapter 5, Lesson 5, Inequalities involving absolute value. Okay, so we're going to kind of go back and remind ourselves what the absolute value of things mean. So if the absolute value of x is 10, that can mean two different things. That can mean that x equals 10, obviously, but it also means, don't forget, that x can also equal negative 10. Because if we take the absolute value of that, it's going to be positive and equal 10. So x in this case could be 10 or negative 10. Now if we have the absolute value of x equals negative 10, then we say, okay, so what number if I take the absolute value of it equals negative 10? Nothing, because every time that I take the absolute value of something, it becomes positive. So this type of problem would have no solution. Now we're going to apply those same ideas to inequalities. So these get a little bit trickier. So we have 4 different types of inequalities that we're going to see. We're going to see the absolute value of something can be greater than a positive number. Like in this first example, absolute value greater than a positive. We're going to see absolute value could be less than a positive. Absolute value is greater than a negative. Absolute value is less than a negative. So those are the 4 types of problems that we're going to be looking at. And we're going to look at what happens in each of them. So if the absolute value of x is greater than 10, that tells me that x could be things like 11, 12, 13. But then I have to remember that it can also be negative 11, negative 12, negative 13. So when I think about that, that means that x can be greater than 10, but it also could be anything that is smaller than negative 10. And since those two things are completely opposite, I'm going to say or x could be less than negative 10. All right, let's look at the one below that, where x is the absolute value of x is less than 10. So this tells me that x could be things like 9, 8, 7, but it could also be negative 9, negative 8, negative 7. So I'm going to say, okay, so x can be less than 10, but then it can't just be anything less than 10, because as what's going to happen is it's going to go 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, but then it's going to keep going smaller, and eventually those things are not going to be true. So it has to be less than 10, and x has to be greater than negative 10, because it can be like negative 9, negative 8, negative 7, but again, it can't just keep going on and on forever. Now let's look at these other two with when the absolute values are greater than or less than a negative. This is where we just have to use some common sense. If the absolute value of x is greater than negative 10, then x can be anything. This is all real numbers, because when we take the absolute value of anything, it becomes a positive, and any positive number is greater than negative 10. This other one is the opposite. The absolute value of x is less than negative 10. Well, that has no solution, because the absolute value of x is always going to be positive, and a positive number can never be less than negative 10. All right, so we're going to follow some steps in order to solve our absolute value inequalities. The first thing that we're going to do is we are going to isolate the absolute value symbols. So if there's anything else that's next to them, that's outside of them, that's under them, we're going to get rid of that. We're going to do just like we solve an equation, and we're going to get that absolute value symbol all by itself. And then we're going to ask ourselves, is this going to be a special solution or not? And so basically we're going to ask ourselves, is the absolute value, whatever's in here, is it greater than a negative number? Or is the absolute value of something less than a negative number? Because if it's greater than a negative number, it's all reals. If it's less than a negative number, it's no solution. And if it doesn't have a special solution, then we're going to set up 2 cases. And those cases are going to be either an AND compound inequality or an OR compound inequality. And so if we have the absolute value of something is greater than a positive number, we're going to set up 2 different cases, and the 2 cases are going to be whatever's inside of that inequality symbol is greater than 10, or whatever's inside of there is less than negative 10. And then our other case would be is if the absolute value of something is less than 10 or less than any positive number. And we're going to set up two cases, and we're going to say, okay, so whatever's inside of there can be less than 10, and whatever's inside of there has to be greater than negative 10. And then we're going to solve our compound inequalities. So let's look at a couple examples. So we have the absolute value of m plus 2 is less than 11. So the first thing I'm going to look for is, are these absolute value symbols isolated? Yes, there's nothing else. It's over here on the other side. So now I'm going to decide, are there any special solutions? Is this number over here on the other side of my absolute value symbol negative? No. So now I need to set up two different inequalities. So I need to say, the first one's always basically just going to be the same. M plus 2 is less than 11. Then I'm going to think about my number line and say, if it's less than 11, it can't go on forever. It also has to be greater than negative 11, because on my number line it has to be between 11 and negative 11. So then I'm going to solve minus 2, m is less than 9, and minus 2 minus 2, m is greater than negative 13, and then I'm going to graph them. And so again, I set up those three number lines. So I have negative 13 and 9, negative 13 and 9, negative 13 and 9. And I say m is less than 9, m is greater than negative 13. It's an and. I look for what they have in common, and they have this part right here in between them in common. Okay, another example. This absolute value of 3n plus 6 is greater than or equal to 12. So I'm going to say, all right, 3n, the absolute value symbol is all by itself. It's not greater than or equal to a negative. So 3n plus 6 is greater than or equal to 12. Will always be my first one. And then I need to decide, is this an and or an or? So if it's bigger than 12, then I know it's going to be 3n plus 6 can be bigger than 12, smaller than negative 12. So then I say, oh, so that's going in opposite directions. It's going to be or. Minus 6, 3n is greater than or equal to 6. Divide by 3, n is greater than or equal to 2. Minus 6, 3n is less than or equal to negative 18. Divide by 3, n is less than or equal to negative 6. And then I'm going to graph it. My three graphs, I have negative 6, 2, negative 6, 2, negative 6, 2. So greater than or equal to 2. Less than or equal to negative 6. It's an or problem. I just combine them. And there's my solution. Okay? Y minus 1, the absolute value is less than negative 2. So I say, okay, the absolute value symbol is by itself. Is it a special solution? Ooh, I see a negative number over here. So if this has to be smaller than negative 2, that cannot be true. This has no solution, because the absolute value of something will never be smaller than a negative. And the last example, the absolute value of 4a minus 1 is greater than negative 21. So the absolute value symbols are by themselves. There's nothing else over there. Is it a special solution? It is greater than negative 21. When you see that negative over there, it means a special solution. The absolute value is greater than a negative. It means all real numbers.